Hi kiddos, welcome to lesson 8. Sorry that today's lesson's later. I was feeling really bad this morning with sinus and allergies and just could not get it together to record. So today we will analyze and model the relationship of position, motion, direction, and speed. So first of all, turn to your teacher-made packet to the page listed about velocity. Velocity is the speed of an object and a specification of its direction of motion. Remember to please pause as much as you need to, replay, do what you need to do so that you don't get lost with the lessons. All right, kiddos, I hope that helped explain the difference between speed, velocity, and acceleration a little bit more. So we're going to look at these pages for just a moment. These are the pages that you're going to be doing during lesson 9 as well. This is a very important part of speed is being able to read these charts. So we're going to be talking about motion, speed, velocity, and acceleration. Remember, motion is just your change in position, and then speed tells us the rate at which an object is going. Velocity is the speed and direction, and acceleration tells us at the rate at which the speed or direction changes. So throughout the course of this unit, we have already been talking quite a bit about distance time graphs, and that's what you're going to be working with. You can see that on the x-axis, we have time, and then on the y-axis, we have distance. We talked about this somewhat when we had the little helicopter on the page. So let's follow along with where I am. So if an object is not moving, a horizontal line is shown on a distance time graph. So for example, this one starts this far from the origin, because here's your origin. It's going to be right here, and even though time is passing, it is not moving. So this is at rest. Now we're going to look at two moving objects. We see that the steeper incline right here, this shows us that it is going further away from the origin in a shorter amount of time than this one right here. Because if we look, you see that right here, with this amount of time, you can see where each of them are at. We have one located this far, and then we have the other one that's this far from the origin. And then we have graphs that show acceleration, which look like this. So it's just putting along kind of slow. It's not getting all that far away from the origin, but time is passing. And then all of a sudden it speeds up and it goes up really quick. That is a sign of acceleration right there. So in summary, a distance time graph tells us how far an object has moved with time. The steeper the graph, the faster the motion. A horizontal line means the object is not changing its position. It is not moving. It is at rest. A downward sloping line means that the object is returning to the start. So remember that this is where it starts from, right? Right here. So it's measuring on this line where it is from the origin. And so if this one is coming back to the origin, I'm not saying that this is the origin, it's just where it started from, because it's measuring on the y-axis how far away it is from the origin. It is coming back to the start. So this right here is a great graph for you to be able to refer back to when working on your problems that you're going to be having. All right, so now you also have this one right here. I don't remember which page this is right off, but know that when you have these descriptions, that you're going to be using one of these twice. Okay, so here you have number 1, number 2, 3, 4, and 5, but you only have 4 descriptions. So you will use one of those twice. Alrighty, let's see what else. I have that you're going to be working with your shoulder buddy, but seeing that you're not at school, that kind of makes it tough. So if you want to work on this with someone on Google Hangouts, that's perfectly fine with me. I do not mind whatsoever, but you're going to solve all of these problems pertaining to these graphs for the lesson tomorrow, for lesson 9. I say tomorrow, but we both know it's really not. All right, so please turn to page 18. Pause me as you need to. I'm trying to roll on so I can get this in on the right time. And you can see I have a few slides left. All right, page 18. Graphs can be used to provide a visual example of objects in motion. Measure of how far the object goes and how long the journey took. Motion graphs may be called distance time graphs. Change in position over time. Makes sense, the name, distance time graphs. Different types of motion can be shown in different graphs. A horizontal line shows that an object is not moving. Different types of motion can be shown in different graphs. A bending line shows that an object is slowing down or speeding up, depending on which way it is bending. Different types of motion can be shown in different graphs. A straight line often shows that an object is moving at a steady pace. Graph rules. Da, 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 da. All graphs should have a title. It must describe what is being measured in the graph. It has an x-axis, and it's going to represent the amount of time. And so the y-axis is going to represent the distance. Then you have units. This is very important. It's also important for this to go away, and it's not. So I'll just pull it out of the way for us. Each axis must be labeled with units showing what is being used for the measurement. So is it using meters, feet, miles, yards, inches, whatever it may be? We have to use that unit. I'm going to put this back, so if you need to pause now for that one, please do so. Key. If more than one line is shown, a key must be used to tell them apart. So you may use a dashed line on one, you may use a solid line on another, or if you're going to use colors, that is fine too. The blue line may represent one thing, and a green line may represent something else. So to summarize this, summarize how distance time graphs can represent the motion of an object. Be sure to describe each axis. So as you can see on page 19, there you have the 4 charts. It is wanting you to describe it above the 4 charts, but in the 4 charts right here are the 4 lines that you need to draw so that you can see. And then you're going to label the X and Y. All I really care about is that you label the X-axis with time and the Y-axis as distance. Then you don't have to do anything on pages 20 and 21, so you may put big X's over those. And then that is where we will stop for today. I want you to make sure that you are doing those problems in the packet. That's very important. And as soon as that is finished, I want you to put this stuff away, and I don't want you to look at it again until the 20th. I want you to enjoy your spring break as much as possible. Spend time with your family, play cards, have fun. Most of your families are on my Facebook page. If they're not, my page is open. I have lots of experiments that you can do on there. I've got experiments posted for you to do on the Google Classroom. Please go have fun as much as possible, and don't worry about this stuff. I know normally you wouldn't anyway, but I want you to have fun. Hope you all have a good spring break. I miss you all dearly, and I can't wait to see you again. I love you bunches. Bye, kiddos.